All right, guys, example 2, it is printed on that page that I handed out to you, but I am actually going to just write it out as well. Yeah, I like having the question when I am discussing it, but you don't have to, obviously. So they're saying the dimensions of a carpet with a length of x meters. So they're telling us what x is in this case, right? In the previous one, we have to say length, the two numbers with x and y. With the length of x meters and the width of y meters are to be changed. Okay, so they're saying we have an original carpet, basically, the length was x and the width was y, but now we're changing it. So they're saying the length, I'm just going to shorten it slightly. It says the length is to be reduced by 3. I'm just going to say the length is reduced by 3 meters and the width by 2 meters. The area of the new carpet is 18 meters squared. So guys, if they're saying that this carpet has a length and a width, what kind of shape can we assume it is in? The rectangle. Hey, it might be square if x and y are equal, but they told us that the length is x and the width is y, and now they're saying the length is reduced by 3 and the width is reduced by 2. And then the area, how do we find the area of a rectangle or square? Same thing. Length times breadth. All right. So we're going to use that, and that is obviously something that you need to know. Okay, they're not going to tell you in the question. Remember, the area of a rectangle is length times breadth. Okay, you do need to know that. Okay, and then they're also saying if the perimeter of the original carpet is 48 meters, and then they're saying determine the dimensions of the original carpet. Now, what were the dimensions of the original carpet? It was just x and y. Right, so we basically need to find x and y. That's what I'm going to write. Find x and y. Oh, that's a bit longer than I thought it would. Just write that out. Okay, so they telling us that the length of the original carpet was x. So that's the original length, the original width was y. Okay, are they giving us other information about the original carpet? They're saying the perimeter of the original carpet was 48 meters. All right, so I'm going to write here original length. I'll just use a cursive R for length so that it doesn't look like a 1 maybe, but you have to like that. So the original length was x and the original breadth. The original breadth was y. Guys, how do you find the perimeter of any shape? Just add all the sides up, right? Now, if it's a rectangle, do we agree that we can have 2 x's and 2 y's? Right? 2 lengths and 2 breadths for a rectangle. So how can I write that? It's going to be 2 of these plus 2 of these. 2x plus 2y, right? That's the perimeter. And what did they tell us? The perimeter was 48. Okay, so I'm just going to say here perimeter is 48 meters. So therefore, now we need to be able to rewrite that using x and y. Okay, so we're using the information that they gave us, and we are writing equations from that information. So like we said, 2 of the lengths, so 2x plus 2 of the breadths, 2y, will be equal to 48. Okay, so now if you want to, let's do the same thing that we did on Friday. It's just underline in the same color. So this perimeter of the original carpet is 48 meters. That is now in blue here. Okay, so we've actually now basically translated that last sentence of the question into an equation. That's basically what word problems are all about. Okay, we need to try and translate whatever they've given us into equation. Okay, now guys, we noticed that we have an x and a y, right? So what are we thinking already? We're going to have to do simultaneous equations. Okay, but we only have one equation. We can't do simultaneous equations with only one, so we need to set up another one. Now remember, what did they say? The length is reduced by 3 meters. So the original length was x. Now what is x when you now reduce it? Well, what is the length when you reduce it by 3? It's going to be x minus 3, okay? When you're reducing it, you're taking away. Okay, so you're making it 3 meters shorter. So I'm going to write here the new length is going to be the original one minus 3. I hope that makes sense, right? It's reduced by 3 meters. And then the new breadth, remember the original breadth was y. Now they're saying, well, sorry, width, breadth and width is the same thing. The width is reduced by 2 meters. So it's going to be y minus 2. Yes? And then what did they tell us about the new carpet? They're saying that the area of the new carpet is 18 meters squared. How do you get the area of a rectangle? You're saying length times breadth. So this times that. Right? So let me just write here, area is 18 meters squared. Therefore, the new length is x minus 3. So that we are multiplying by the new width, the new breadth, y minus 2, and the answer must be 18. Guys, it is very important that you put those dimensions in brackets. So you have to take the whole new length multiplied by the whole new width. Okay, so you can't just say x minus 2 times y, x minus 3 times y minus 2. You have to multiply the whole thing. Okay, so this equation here is coming from area of the new carpet is 8. So again, we've taken information given in words and we've translated it to another equation. Now we see we have 2 equations, right? With 2 variables. So now we can start solving them simultaneously. The first step in solving a simultaneous equation, or simultaneous equations, rather, is we need to isolate the variable. So guys, I wouldn't try to isolate the variable here. It's going to be very complicated, right? Because say you're deciding to make x the subject here. You want to get x on its own. You're going to have to say 18, you must divide by the whole bracket, and then you must add a 3. Please don't do that. That will be a mess. Let's look at this. Okay? Now there are 2 that start with both of these variables, but it's actually not that bad because 2 can actually divide into all of these. Alright? So which one do you want to make the subject? X or Y? It's up to you guys. X, okay? So we're going to say 2x is going to be 48 minus 2y. Right? I'm moving that plus 2y to the other side. It becomes minus 2y. Are we fine with that step? But now to get rid of the 2 in front, I must divide the other side by 2. Everything on the other side, guys, can I divide 48 by 2? Yes. And what about negative 2y? Can I divide that by 2? Yes. Okay. So we're going to say x is equal to, what is 48 divided by 2? 24. But we must divide the negative 2y by 2 as well. Okay, and that is going to give us negative y. Right, so usually we try and avoid that kind of situation. We try and avoid a variable with a number in front of it. But in this case, it actually wasn't that bad because that number could divide into both of those terms. Okay, we weren't left with fractions. If that was a 3 in front, then it would have been a different story. Okay. Now, what do I do with this 24 minus y? I'm going to put it in x's place in the other equation. Right? Yes. I'm just going to rewrite this on a different page, guys. I'm running out of space. So if you got to rewrite this now, if you still have space. So I just said that x is 24 minus y, and I also have this equation. This is the other equation. Okay. Now I'm going to put this in the place of x there. So I'm going to have, instead of just x minus 3, I'm now going to have 24 minus y minus 3. Right? Right, I think it's squeezing. And then I'm just going to rewrite everything else. If you want, again, you can take a highlighter now if you have a third one. That's a different color, and you can just show that this 24 minus y is now going in the place of that x. Okay, that's what's happening here. Oh, hello. How is that? That's the previous lesson recording. Okay, there we go. Now, guys, I wouldn't try and multiply this out just yet, because when we see in that first bracket, we actually have a 24 minus 3 that we can work out, right? What's 24 minus 3? 21. So let's, instead of doing 3 terms and 2 terms, let's make it easier for ourselves. Let's simplify that first bracket. 24 minus 3 is 21. Minus y in the first bracket, and then the y minus 2 in the second bracket, and that is equal to 18. And now we're going to solve simultaneously, right? So we're going to say, we're going to FOIL. 21 times y is 21y. Outers, 21 times negative 2, negative 42. Then we have negative y times y is negative y squared. Then we have negative y times negative 2 is positive 2y, and that was equal to 18. What type of equation is this? Quadratic, right? Because of that, y squared. So we need to write it in standard form. So let's put the y squared in the front. So we have negative y squared. Okay, let's look for all our y terms. We have 21y and then plus 2y. That's 23y, right? So plus 23y. Now let's look for our constant terms, the ones that are just numbers. We have negative 42 and then positive 18 on the other side. When I move it, it's going to become minus 18. So we have negative 42 minus 18. That is negative 60, right? And then that is equal to 0. Okay, now we can use the quadratic formula, okay? So y is equal to, my b value is 23, so we're going to say negative 23 plus or minus the square root of b squared. So 23 squared minus 4. Now what is my a value in this case, guys? Negative 1, good, well done. And then my c value is negative 60. All over 2 times a, which is negative 1 again. We must remember that one. Over 2 times negative 1. Okay, let's see what we get. Okay, so I am getting y equals 3. And I'm putting a plus there. And for my second value for y, I am getting 20. Now remember, what was y originally? Y was the width of the original carpet. Okay? So I mean, y could be 3 or y could be 20. Right? So what do we do with those two y values? Supplement get 2x values. All right. So remember, we're going to, thank you for that. We're going to write y equals 3. So if y is 3, then x is going to be, remember here, 24 minus y. 24 minus 3, which is 21. Okay. Or if y is 20, then x is again 24 minus y. I'm getting it from this equation here at the top. So 24 minus 20, so x is then 4. Okay, so that is saying that, remember they're asking for the dimensions of the original carpet. So for this first set of answers, we have a 21 meter by 3 meter carpet. All right, that could happen, right? It's a very long room or carpet, and then it's quite narrow. Or we could have a 4 meter length and then a 20 meter breadth, which is a bit hard. Right? Usually the length is longer than the breadth, but it's fine, it doesn't really matter. Okay, so let's just finish this question off. Guys, with word problems, it's a good idea at the end to not just leave your answer like this. I mean, this is fine, but just to actually contextualize it and just say, what does that actually mean? Okay, because in the wording, it said, determine the dimensions of the original carpet. All right, so we can just say 21 meters by 3 meters. That's normally how we write dimensions, right? Or what is this? 4 meters by 20. Okay. Now guys, before I move on to the third example, I want you to do a question in the textbook that is like this one. So it is going to be, because the third example is now very different from the ones that we've done so far. So I don't want you guys to get confused. So it is exercise 7. On page 34, I want you to do number 9. And that is the only reason why number 9 is similar to this one, and because it's again working with rectangles. So I'll put the question on the board. But we're not actually working with x and y this time, we're just working with x. Okay, so they're saying a rectangular parking area has dimensions of 50 meters by 120 meters. So they've given us the original dimension. Okay? They've given us the original ones. If the parking area is doubled by increasing both the length and the breadth by x meters. So there they're showing us on the picture. All right, so they're saying your original length was 120, now it's 120 plus x. The original breadth was 50, now it's 50 plus x. But what they're saying is that the original parking area has now been doubled. So guys, how can you find the area of the original parking lot? 50 times 120, right? And then they're saying that this area is double that. Okay, so you actually can calculate the new area. So the original area, all right, here at the bottom. So the original area is 50 times 120, which is, I suppose it's 6,000, which is 6,000 meters squared, right? Now they're saying that the original parking area is double. So what is this new parking area going to be? 12,000. Right, does that make sense? So you can use the values that they've given you here, just by knowing that the area of a rectangle is length times breadth. So the original area is 6,000 meters. Then the new area is going to be 12,000 meters squared, whereas it's meters per squared. And then how does that help us? How do we find the area of a rectangle? Length times breadth. 120 plus x times 50 plus x. All right, and can you then calculate x using that? Because we know that the answer should then be 12,000. Okay, so the information is given in a slightly different way, but that's kind of how you need to get going. Okay, so see if you can do that on your own, guys. Just lay it out nicely. So you will start by writing what I wrote on the left. Original area equals that times that equals 6,000. Therefore, new area equals 12,000. Then you take on the equation and then you solve it. Okay, do that on your own, please, guys. Okay, so I wrote the original area is 120 and 6,000, right? That's what we wrote on the side there. Therefore, the new area is just double that. So they say the parking area is double. Okay, let's do that one as well. So then to get the new area, you would have to take the new length multiplied by the new brick, right? Which was also given 120 plus x, that is the new length multiplied by the new brick, and that will then have to give you the new area. So then I just FOILed them out, right? So 120 times 50 is 6,000. 120 times x is 120x, x times 50 is 50x, and then x times x is x squared. And that again was equal to 12,000. Then I saw that there's an x squared, so it's a quadratic equation. So I must get everything on the one side and make it equal to 0. So my x squared I just wrote in front. 120x plus 50x is 170x, right? Then here we have a positive 6,000, but now we're going to minus 12,000 from it when we move that. So that's where the negative 6,000 comes from. I used my quadratic formula. I got my 2x values. Now guys, remember x in this case was now length that has been added to the original dimension. So x can't be negative. I mean, you could take away length from it, but then your area won't double. All right, so in the context of this question, we couldn't have a negative 200 there. So then they didn't only ask for x, guys. With these word problems, you also need to be careful. You need to make sure what are they actually asking. Okay, so they said in the question, determine the dimensions of the new parking area. Now remember the dimensions were 120 plus x. So now 120 plus 30. So that's where that 150 is coming from, right? And the other one was 50 plus x, so 50 plus 30. So that's where that 80 meters is coming from. So if you don't have that last line, or if you don't have at least just 180 by 50, then you'll lose them all. Okay, because that's what they're actually asking for. Can't just stop with x. Sometimes the answer will just be x, but sometimes you need to go a step further and actually use that x value to answer the question. Okay. Any questions on this one, right? All right, we're going to do example 3 now, which is a speed, distance, time example. And I have a very specific way of doing speed, distance, time questions. Right? So that everyone has it copied down. So I will go to the next page just now. Okay, let's go through. Okay. Are your projects coming done? Are they coming or not? Are they in the work? I know experiments that we need to try to get not this week, and next week is going to be hectic. And I'm getting on Tuesday next week. Okay, so you have to have your experiments done this week, please. Tuesday is. Okay, example 3. Here we go. All right, copy that down because it's also on the page. You don't have to copy it down because I want to. It's quite nice, like underlining and but it's fine if you don't want to copy it down. You don't have to. We'll just give some time for those of you that want to. Guys, I'm just adding something to the heading there, but you can also just add increase For speed, distance, time, question, I suggest very strongly that you use the table. Okay, it makes things easier and often it's not just setting up the table without even setting up the equation. So whenever you see that it's a speed, distance, time question, we are going to use the table for that. Okay, we're also going to practice one for homework, which I need you to use a table for as well. They might. So sometimes they give you a table and they fill it in and then do the thing. But they might also just. But then I want you to remember to use the table. I promise it is the very best way of doing it. And guys, when I was at school, I'm going to be honest with you, I just read for it. I never even tried it. But sometimes you can get it off too, just for like setting things up, okay? And especially with these ones, just for doing the table. So what I'm trying to say is I also struggle with it, okay? But the table really works very well. It makes it much easier. And I just see it was actually nice one for me. Okay, so that's the first important thing. When you see speed, distance, time, you are going to set up a table. And guys, regardless of the information that's given, you don't even need to worry about what comes first. You can literally just say, in this case, let's just quickly see what are we comparing here. We're saying if the speed of Miguel's new car is 10 kilometers per hour faster than that of his older car. All right, so there was an old car and there was a new car. All right, so that's what I'll put here. I'll say old car and then new car. And it's also a good idea to start with the original or the old or the previous, right? And then on it. We can do old car, new car, and then I'm just going to say here, literally speed, and then distance, and then time. And then you're just going to pull it in the fact that we can pull it from it. Okay, so the order of your products, I always use speed, distance, time in that order. And guys, the reason for that is because that order is going to help you to remember the formula. Right? So the speed, distance, time formula, it is also on this page that I handed out the other day, but I'm going to write it down now as well. But it is there at the bottom. I know it's very small, but it says there that speed is distance over time. So if you remember speed, distance, time, you are also actually remembering the formula, right? Speed is distance over time. Now, guys, in previous grades, did you work with the triangle? Right, so we can do that as well. So for the triangle, a way of remembering it is to use I think some people say. So you can just draw a triangle. And this is just a way of getting all three formulas quite easily. Right, so you can just have like a top section, and then I usually just put the bottom one in half. And you have a D and an S and a T. That. Right, so like you like the triangle supposed to be an upside down view. That helps you remember what comes first. Or you can just remember that it's an alphabetical order, right? You can then see that's the way it works. But guys, what this triangle is telling you is that if you are calculating distance, you have to take speed times time. They're next to each other, right? And when two letters are next to each other, we are multiplying them together. So distance is speed times time. If you're finding speed, it's distance over time. You see that? If you need to find time, it's distance over speed. Okay, so this is a nice way of actually remembering all three formulas, because you might have to calculate distance sometimes you need to find speed, other times you need to find time. So I'll just write it on the side here. D is equal to S times T. Distance is speed times time. Right? Then we can say that speed is distance over time. Speed is distance over time. See that from the time, right? So going the other way, time will be distance over speed. Okay, so that triangle is really helpful. And guys, we're not going to give you that triangle, we're not going to give you those formulas. All right, you can get a question like this in a future exam, and you need to know those formulas. Okay, so I suggest that you memorize that final. It's very useful. Okay, so we said a lot of stuff now. We haven't actually started doing the question, right? So I'm just going to repeat. We're going to read through it now again in detail. We haven't actually done that. I'm just repeating that when you see that it's a question about speed, distance, and time, you draw a table, all right? And like I said, without even reading through everything that's given, you can just check what are they comparing here, speed of his old car and speed of his new car, all right? So we can put that there. And then speed, distance, time. And now we're going to start putting stuff in. Okay. So what are they saying here? If the speed of Miguel's new car is 10 kilometers per hour faster than that of his older car, the journey between George and Riversdale, which is 100 kilometers apart, will be shortened by 30 minutes. So they're comparing how long it takes the old car to drive 100 kilometers with how long it takes the new car to drive 100 kilometers. So do we agree that the distance is the same? Right? I'm going from George to Riversdale, it's 100 kilometers. Okay, whether you're driving with the old car or the new car. So we can fill this one in. This one is 100 kilometers. That one is also 100 kilometers. Okay. And it will usually be like that, right? The distance will usually be okay. Because they're normally comparing speed times as well. Okay, so we're talking about one trip from George to Riversdale, that's 100 kilometers. Now, the important thing here is we need to look at what they're actually asking us for, and that we need to make equal to x. So they're saying determine the speed of the new car, and that we are making equal to x, okay? So determine the speed of the new car. So that we are going to make equal to x. Now you're looking at your table. Where is the speed of the new car? There. So there you're going to put in x. And that's what kilometers per hour, hey? Kilometers per hour. So now, guys, the other stuff they didn't give us, that's what they've given us. Okay? They haven't really given us what this is x, but the fact that they're asking us for that, that is what we need to do. Now, what if they tell us about the speed of the old car? Well, they're saying, so you're almost there, they're saying the speed of the new car is 10 kilometers per hour faster than that of his older car. So can I say that the older car is 10 kilometers per hour slower than the new car? Does that make sense? If the new car is 10 kilometers per hour faster, then I can go the other way around. I can say that the older car, because we need to write now the speed of the old car, right? We have the one for the new car. We need to write the speed of the old car. So if this one is x, the old car is 10 kilometers per hour slower than the new car. Does that make sense? So what is 10 slower than x? X minus 10. You call that confused? Okay. So when we're reading, maybe we want to just do an underlining thing here. So the fact that they're saying here that the speed is 10 kilometers per hour faster than that of his older car, that is what they're putting in there. Okay. So that's where that x minus 10 is not. We can also do our distance here. So this distance is there and there, all right? The distance is the same. But now it's going to be time. About did they tell us how long it takes the old car or how long it takes the new car? Did they give us actual time? Let's read what are they saying? This is saying the journey will be shortened by 50 minutes. But they haven't actually told us how long and how long. So now, guys, for the time, we're going to have to use the time formula. Okay, so let's make an arrow from this time formula here to the time column in our table. We are actually going to have to use the time formula to figure out what the time is going to be. And they didn't give us the times, so we need to use the formula for it. Okay, now guys, time is distance over speed. Now we're going to use what we have in our table already. The distance for the old car is 100 kilometers over the speed, which was x minus 10. All right, so the time here for the old car is going to be 100 over x minus 10. So you use the formula along with what you already have in your table. Okay. So it will always work like that, right? You'll always be able to fill in two of the columns, and then for the third column, you need to use the formula. Yes.
So now, what could it be possible if we were to have a y there? That's fine, right? For the new column, would be y minus 6.
Yes, but then you're going to have to again do the simultaneous equations. But yeah, sure, you can do it like that. Okay, we're trying another step. Using the formula there. Distance over speed. Time is distance over speed. Okay, and for this one, time of the new car is also distance over speed, but now it's going to be 100 over x, right? So 100 over x. So that's your table then. So guys, in order to figure out, in order to calculate the value of x, in order to find the speed of the new car, we need an equation. Right? So now we need to read through. Remember here they said the journey will be shortened by 50 minutes. So when this guy is driving his new car, the time will be 30 minutes less than when he is driving the old car. Now I'm going to say that again. In the new car, the time of the journey will be 30 minutes less than in the old car. So now we need to use that information to set up an equation. All right, so I'm going to use my yellow, which I think you guys can see when it's on the board. Hey, so this shortened by 30 minutes. We all agree that 30 minutes is time. All right, so obviously they're comparing time. And we need to use these values now. And that 30-minute difference to set up an equation. Now this is normally where things go over to. Actually setting up the equation is normally the difficult part, I think. But sometimes the language is so a bit confusing. Guys, which journey is longer? I normally like doing a minus. Okay, so which car will give you a longer journey? Which time will give you a longer one? The old one, right? So this one is bigger, a longer time than this one, right? So this is bigger, or let's rather say longer time, and this one is shorter. And what is the difference between the two? 30 minutes, right? So now you can decide, right? You can say, okay, the longer time minus 30 minutes will be equal to the shorter one. Okay? So the time of the old car minus half an hour will be the same as the time of the new car. Does that make sense? Or you can go the other way around and say the time of the new car, if I add half an hour to that, it will be the same as the time of the old car. Right? Does that make sense? Now, something that also just comes into the mix here, this is 30 minutes, but these are kilometers per hour. So 30 minutes is actually half an hour. Okay, just add that there. Sorry, that complicates things a bit. We can't use 30 in our equation. Okay, we have to use hour. Sorry, that's another complication here. So we have to use a half. Can't use 30. Okay, so guys, I'm actually going to write down two separate equations here. So I'm going to say you can either do, so this will be option 1, you can do old car minus half hour will be equal to the time of the new car. Right, does that make sense? So say you take 2.5 hours when you're driving in the old car, but when you're driving in the new car, it only takes 2 hours. Right? So the time of the old car minus half an hour is the time of the new car. Or the second option, you can say the new car plus half an hour will be equal to the time of the old car. So I say the new car takes 2 hours, but the half an hour takes 2.5 hours in the old car. Okay, so always the same try and figure it out when it works out, or just logically. Which one do you guys want to go with, the minus or the plus? You can decide. The plus. Okay, the time we carry on with this one. All right. So I'm going to do option 2. So we're going to say the time of the new car using our table was 100 over x. Now the time of the new car, when I add half an hour to it, the plus of half will give me the time of the old car. It's 100 over x time. So that really helps to actually describe it out in words, but and then you use the actual time from here. What is the time of the new car? That's what. That's the half equal to that one. Okay, makes it a bit easier. And guys, what kind of equation is this? An equation with fractions, our favorite, right? What do we do when we have an equation with fractions? We multiply each term by the LCD. And guys, in this case, the LCD is a bit complicated, right? The LCD has to have a 2 in it, and an x, and then an x minus 10 in a bracket, okay? So the LCD here is 2x times x minus 10. All right, that's a complicated LCD. So it needs to have the 2 and x on its own, and this bracket on its own. Okay. So I'm going to write here times 2x, x minus 10, times 2x, x minus 10, times 2x, x minus 10. Okay, now we can cancel out those denominators, right? If we're looking at the first fraction, the x at the bottom is going to cancel out the x in that we're timesing it by. So what am I left with, guys? 100 and a 2, which is 200, right? If I times it. So 200 and then that bracket. So 200 x minus 10. Okay, that's what's left from that first term. Plus the second fraction, what's cancelling out? The 2 at the bottom with the 2 at the top. Yes. So there's a 1x, which is just x and x minus 10. So x and x minus 10. That is then equal to okay, so in the last fraction, the x minus 10 and the x minus 10, those cancel out. So what am I left with? 100 times 2x. 200x, right? And then your homework is to solve for x in this equation, please. You're going to multiply the brackets out, get everything on one side, equal to 0, and solve for x. Remember that x is a speed. So x can't be negative, right? Okay, that is your homework, guys. That's all you need to do for tomorrow. Thank you. That was quite a full lesson in terms of content. You guys did well.